Alright, so here we are on lesson 2 of our statistics unit called displaying a data distribution. Our I can statement is, I can, when given a dot plot, describe the distribution of the points on the dot plot in terms of center and variability. Remember from yesterday, variability, its base word is vary, which means change. So I can describe it in terms of the amount that it changes. Okay, here's our first problem let's look at. America, a 7th grader at Pine Middle School, was thinking about joining the middle school track team. She read that Olympic athletes have lower resting heart rates than most people. She wondered about her own heart rate and how it would compare to other students. America was investigating the question, what are the heart rates of the students in my 7th grade class? So I want you to think, is this question a statistical question? What are the heart rates in my 7th grade class? Well, let's see what we remember from yesterday. For it to be a statistical question, we have to collect data from more than one item. So we're collecting it from the whole 7th grade class. And is there only one possible response? Well, the answer is yes, it is a statistical question. Why? Well, because someone could have a heart rate of 80, another person could have a heart rate of 83, another person could have a heart rate of 90. So these are all different numerical values. So it is a statistical question because there is that variability or that change. Okay, here's our next one. Heart rates are expressed as beats per minute or BPM. America knew her resting heart rate was 80 beats per minute. She asked her teacher if she could collect the heart rates of the other students in her class. With the teacher's help, the other 7th graders in her class found their heart rates and reported them to America. Following are the heart rates in beats per minute for the 22 other students in America's class. Is this still a statistical question now because we have data that repeats? So look right here. I noticed right away that I have an 88 and an 88. I have 83s repeated several times. Is this still a statistical question because I have the numbers that are repeated? Well, the answer is yes. It's still a statistical question because the data has variability or differences in it. We're allowed to have data that has the same numbers because we didn't force people to have 83. We didn't force people to have a heart rate of 88. So it's all about that variability, or is there the option for there to be change or differences in that data? Okay, let's look at our next one. To learn about the heart rates, a good place to start is to make a graph of the data. There are several different graphs that could be used, including the 3 types of graphs that you'll learn about in this unit or module. Dot plots, histograms, and box plots. In this lesson, we're going to learn about dot plots. So here we have our data again, and let's think, I'm going to make a dot plot. What do you think a dot plot will have? Well, hopefully you realized it's probably going to have dots since that's in its name. Okay, so America noticed that there are many different heart rates. She decided to make a dot plot to show different heart rates. She drew a number line and started numbering from 78 to 92. If you'll notice here, I cut it off at 90 just because there's no 92 value. She then placed a dot above the number on the number line for each heart rate. If there's already a dot above a number line, she added another dot above the one that was already there. She continued until she added 1 dot for each heart rate. So today's lesson is not focusing on making a dot plot. That will be a later lesson. But just so we can see the idea, saying she looked at this number, 89, and she just put a dot there. She went to 87, right here, put a dot, and she kept continuing until she had done that for the whole entire data. So here's our dot graph. Okay, let's watch this short video now on making a dot plot.
So we're going to represent the following data with a dot plot. A dot plot is a very useful way of plotting fairly simple data. Basically, every point on the number line we put a dot whenever we get a data point there. So what we're going to record is the number of siblings. We're going to ask a class of children how many siblings they've got, and we're going to tally each response. So you can see that there are 4 people who are only children. 12 of them have 1 brother or sister. 9 have 2 brothers and sisters. 3 have 3. 1 person has 4 siblings. No one has 5 siblings, but we have 1 person with 6 and 1 person with 7. and 0 have 8 or more. So we just draw our number line. We can start and end our number line wherever is sensible for the data. We're going to go from 0 up to 8. Even though no one has 8, we'll put that on there. And we just start putting dots on wherever we need to. 4 dots at 0, 12 dots at 1, 9 dots at 2, 3 dots at 3, a dot at 4, nothing at 5, a dot at 6 and 7. And that's our dot plot there. Now something that makes a dot plot really useful is that we can continually add data to it until we're done. For example, if 6 new people show up the following day and want their data added to the chart, we can quickly update the tally count, and now it's a very simple case just to add those last few data points to the chart. Okay, so that's how you make a dot plot. It's a nice simple way to describe your data. You can see the shape of the data and the spread on the data, and that's it.
Alright, so now let's look at our dot plot. What can you tell me about the heart rates of the 6th grade students? Where do the heart rates tend to center? Why do you choose that number? And how much spread do you see in the heart rates? Well, let's look at this first question. What can you tell me about the heart rates of 6th grade students? Well, I can say that they range from 79 to 90. I could say that it looks like the most common heart rate is 83. I could also say that it looks like most heart ranges or heart rates are between 82 and 88. Those are all things I can use to tell you about their heart rates. Let's look at this next question. Where do the heart rates tend to center? Well, we haven't learned what center means in statistics yet, so there's several possible answers. I could say that looks like it centers around 83 because that's my biggest number. I could say that centers around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 numbers, so I can just pick the one in that middle. So I could say it centers around 85. Either way is acceptable as long as I give that justification. So if I say 85, I should say, well, it's 85 because that number is in the middle. If I say it centers around 83, I'd say it centers around 83 because that is my most common number. This last one's a little bit different. How much spread do you see in the heart rates? Well, I see some spread because I'm going all the way from 79 up to 90. So I see a little bit of spread, but not that much. Okay. Let's look at this dot plot to answer these questions. What is the heart rate for the student with the lowest heart rate? Well, that lowest heart rate is 79. So my next one, what was the heart rate for the student with the highest heart rate? I look at my highest number is 90. So my highest heart rate is 90. How many students had a heart rate greater than 86? So this is asking just for 86, it's saying greater. So it's not 86, doesn't say greater than or equal to, just greater. So that's 1, 2, 3, 4, 5. So I have 5 that have a greater heart rate. Okay, this one's different. What fraction of the students had a heart rate less than 82? Well, there's 1, 2, but it's asking for what? A fraction. So this is my part, and now I need to make it over a whole. So it's going to be 2 parts out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So 2 out of 22, or I can simplify that to what? To 1 over 11. Now here's my last one for this. What was the most common heart rate? Well, I see that my most common, or the most frequent, is right here, which was at 83. So it's pretty easy to look at and read a dot plot. Let's use our dot plot to continue answering some questions. What heart rate describes the center of the data? Well, we already discussed that there's several possible answers. So it could be that 85. since it's right in the middle, or it could be that 83 because it's the most common. Let's look at this next one. What heart rates are the most unusual? Unusual means not very likely, or we probably wouldn't expect. Well, 90 is on the outside, and so is 79. They're most unusual because they're just not occurring very often. What we have is called outliers. Your data points that are kind of by themselves are called outliers. So it looks like I didn't fix that one up either. So it is 79 and that 90. Okay, here's our next one. If America's teacher asked what the typical heart rate is for 7th graders in class, what would you tell America's teacher? Well, remember, typical means what? Typical means the regular, usual, normal, any one of those. So I can look, what looks like the regular heart rates? Well, most of my data is between what? 82 and 86. If I want, I can say 82 and 88 because there's a high number over here. But I'm looking for my regular or usual. So I'm going to say that most students had a heart rate between 82 and 86. The most common was that 83 beats per minute. Okay, my very last one is asking me on the dot plot, add a dot for America's heart rate. Well, I'm going to have to refer back all the way to my original problem. Now, what do I notice in this original problem? I'm looking for what? America's heart rate. America knew her resting heart rate was 80 beats per minute. So I had to go back and reread. So now I have my information that I can now plot on my dot plot. 80 beats per minute would go right there. So I just added that dot right above 80. Alright, now let's look. Here's completely different problems. Let's listen to an explanation of them.
America's class collected data to answer several other questions about her class. After they collected data, they drew dot plots of their findings. Here's a dot plot showing the data collected to answer the question, how many textbooks are in the desks of 7th graders?
So here's a dot plot that shows how many textbooks are in a student's desk at school. Here's another dot plot referring to America's class.
When the students thought about this question, many said that they all had about the same number of books in their desk, since they all take the same subjects in school. The class noticed that the graph was not very spread out, since there were only 4 different answers that students gave. With most of the students answering, they had 6 books in their desk. Another student wanted to ask the question, how tall are the 6th graders in our class? When students thought about this question, they thought that the heights would be spread out, since there were some shorter students and some very tall students in class. Here is a dot plot of the student's height.
Okay, now let's look at these two dot plots of textbooks and height and think, which dot plot has the greater variability or spread? Well, I know variability means spread also because it has that comma, giving us that definition. Variability also means what? Also means that change or difference. So which of these dot plots has the biggest change in it? Well, I can just look and I can see that the height has the greater variability. My textbooks only go from 5 to 8. So that's only a variability of 3. 8 minus 5 equals 3. My height, though, I have variability from 49 all the way up to 66. So that's a variability of 17. So I have a greater change or variability in this height. Alright, here's our last problem before we do our lesson summary. Match each statistical question with the appropriate dot plot. Explain each of your choices. What are the ages of 4th graders in our school? What are the heights of players on the 8th grade boys basketball team? How many hours do 6th graders in our class watch TV on a school night? And how many different languages do students in our class speak? Well, I don't have a lot of information to work with because I don't have any labels, so I'm going to have to think, what are some guesses that are educated? Well, here I only have a variability of 2 data points. So let's see if this one makes sense for any. The ages of 4th graders in our school. Well, I know almost all of our 4th graders right now are 10 years old. And that's one of my data points. Does it make sense that I might have some 9 years old? Well, I think so, but let's just check. What are the heights of players on the 8th grade boys basketball team? Can a boy be 9 feet tall, 9 inches tall? Not likely, so it's not going to be this one for A. How many hours do 6th graders in our class watch TV on a school night? Well, do we think everyone watches either 9 or 10 hours? Probably not. So it's not going to be this one either. How different languages do students in our class speak? I don't know anyone who speaks 9 languages or 10. So this one right here, the only one that makes sense is with question number 1. I'm just going to cross it out now so we know that we've used it. Let's look at our next one. What are the heights of players on the 8th grade boys basketball team? Well, can I have a boy who's 0 inches tall or 0 feet tall? I can't, so I know it's not going to be B. Let's look at C. Can I have a height of someone who's 1 inch tall or 1 foot tall? No, so it's not going to be C. Can I have the height of someone in 8th grade who's 58 inches tall or 58 feet tall? Yes, I can. 58 inches tall makes sense. That's a little less than 5 feet. It's 4 feet, 10 inches. So it does make sense if D is referring to heights. Let's cross it out so we know we're not using it again. Okay, now for number 3. How many hours do 6th graders in our class watch TV on a school night? Well, let's check with this first one. Do I think some people watch 0 hours of TV? Yeah. Do I think some watch 1 hour of TV? Could be. 2 hours? Yeah. 3 hours? It's maybe okay. 4 hours? I can see that. 5 hours? 6 hours? 7 hours? Or 8 hours? I really don't think anyone is watching 8 hours of TV, 7 hours of TV a night on a school night. Just because of sports, your reading log that you should be doing, and probably your parents just not letting you. But I'm not sure, so I'm just going to see if this one makes sense, or makes more sense. How many hours do 6th graders in our school watch TV on a school night? 1, 2, or 3 hours? Well, that one makes sense too. So I'm not quite sure between these two because they both make sense. So let's check number 4 and see if we can figure this one out. How many different languages do students in our class speak? Well, I know right away that some speak at least one language, English. So I know this one, B, will not go with 4 because this is telling me they don't speak any language at all. So what about C? Yeah, some students could speak one language. Some speak Spanish and English. And some might speak Spanish, English, and Filipino, or some other language. So 4 is going to go with that C, which means that, yes, number 3 is B. Some students are watching 8 hours of TV, even though that seems ridiculously long. Alright, so here's our lesson summary. In this lesson, numerical data collected to answer a statistical question was shown in a dot plot. In a dot plot, the value is represented by a dot over a number line. So we say that's plot the dot. The number of dots over the number line at a particular value tells you how many of the data points have at that value. A dot plot can help you find the largest and smallest value, see how spread out the data are, and see where the center of the data is. Okay, here is your exit ticket. When you are done, you're going to go back onto Dreambox, and you are on Dreambox until the end of the day. Alright, good job today, guys.